Good morning, Year 6. Today I'm going to be moving on with our measurement lessons, and we're going to be looking at the topic of angles and degrees. Now, so far what we've been talking about with measurement is measuring along a straight line, whether it's the edge of a triangle, the edge of a rectangle. It's always along a straight edge. Now, it is necessary to be able to also measure along a curved edge. If you remember this device here, remember what it was called? The click wheel. Yes, this is a circle that was meant to measure along a straight line, but sometimes you are also required to measure along a curved line. And while the measuring on a curved line is something in itself, we want to measure something that occurs within a circle, and those are called angles. Now, an angle, if you've looked up this word already, an angle, simply put, is the measurement of space between two lines. Okay, now the thing is, the lines that we're talking about are not parallel lines, okay? And we're not talking about a measurement of space like that in centimeters or meters. What we're talking about are lines that converge, that meet, okay? So we are going to be looking at something like this, where two lines meet. There is a measurement of space between them. But here's the problem. You can't use an ordinary straight line measurement for this simple reason. If you measure further away from that point, you'll get a measurement. I'm getting 27 centimeters here. If you measure closer to that point, now you are getting 7 centimeters. So with maths, we know that it's got to be something that is constant, that is repeatable, and that is predictable. And having a measurement like that, which varies so much, is not predictable. That is where an instrument like this comes in. Now, you have probably seen them half like this. They come in a mat set. This one happens to be a complete circle. And we use a device like this that's called a protractor. I'll write it down here. We use this protractor to measure angles and degrees. Now, what happens when two lines meet? The point at which they meet is called a vertex. One of our vocabulary words. The point at which two lines meet is called a vertex. Another word that you might be familiar with is a corner, or a point, or the summit, the peak of a mountain, the top of, or a point at where things all come together. In maths, we call it a vertex. And the measurement is around that vertex. So it's not a straight line. We're not looking at a straight line measurement. That would be wrong, because as we came closer to the vertex, that measurement would change. We're looking at a measurement around that vertex. So when this line, let's say this is line A, when it separates from line B like that, around that point we have what is called an angle being created. The angle is how the two lines relate to each other, or how quickly or how slowly they come together or move away from each other, depending on which way you want to look at it. We are talking about an angle, and they are measured in degrees. Now, these degrees are not the degrees that you'll go and study at a university. They are marked along the edge of your protractor. And the thing with this device is that even though this one is quite huge and this one is fairly small in comparison, if you look at the measurements on here compared to the measurements on here, you'd probably say there's no ways that these two can measure the same angles. But this is the thing about degrees and angles. They can, they do. They can measure the same and they do measure the same. I'm going to show you just now. It doesn't matter how far apart these lines go or how close they come together. The angle and the degrees that you will measure will always be the same. And this is exactly what we're looking for in maths. Something that is predictable and something that is repeatable. So when we're measuring, it is important to note that there is a finite amount of degrees that you'll ever find. So imagine that this is a full circle, okay? And we're just looking at the angles on that circle where our two lines meet at this vertex. Our full circle would have 360 degrees. You have probably heard this before. Whether you're watching soccer, whether you're watching basketball, whether you're watching mountain biking or extreme sports, when somebody does a stunt and they basically complete a full rotation, they do one full turn, it's called, did you see that 360? What an amazing 360 spin. 360 degrees is basically saying, I have turned a full rotation and I've faced back to where I started. That is 360 degrees. It is a full circle. Now, when we're not looking at a full circle and we're only wanting to look at a portion of the circle or portion of that rotation, this is where these devices called protractors come into the mix. And it's very simple to use them. Along this edge here, along this edge, I'll just make it blue so you can see it. Along that edge, you just line up with, let's say, line A, okay? And then where you see this dot here in the middle, that is where you place the vertex. You want the vertex to be visible right in that gap. And then all you do is once your line A is lined up with the bottom, is you follow the scale up until you see wherever line B is coming through, and that's how many degrees the angle is that you're measuring. Now pay attention to this here. You have got a scale that goes from 1 through 90 to 180. And then on the other side you've got a scale that goes from, this was from 0, not from 1. From 0 through 90 to 180 also. Now all that is there for is in case your line B is not opening this way, but it is opening this way. Sorry, Sadie just walked in. So what we're talking about here is your line B could either open this way, in which case you'll follow the 0 scale up this way, or it could open from this side, going this way, in which case you will follow the 0 scale up that way. And just as a case in point, you'll see that this is 180 degrees. What's a half of 360 degrees? 180 degrees, half a circle, 180 degrees, full circle, 360 degrees. So I'm just going to do a quick demonstration to show that even though these two are very different in size, and the measurements that you see here seem so different, they do actually measure the same angle. This bigger protractor is just to measure greater lines, greater angles, longer lines on the board. The angles that they will measure will be identical. So first thing I need to do is to line up my scale. It's opening this way from line A to line B. So let me just point the arrow in the other way to make it less confusing. Stick it that way around. So our line A is opening up that way. So all I've got to do is align my vertex, get the bottom line in line with line A, and follow the 0 scale. 10 degrees, 20 degrees, 30 degrees, 40 degrees, and this we'll call 40, the line's very thick, we'll call it a nice round 45 degrees. Okay. And that is the SI unit for degrees. It's that little round symbol next to your number. It's to show that you've measured it on a scale which is circular. Now if I take this small protractor and I put it on, you might find this very hard to see, but I hope you can squint and figure it out. Try and line it up also on the vertex, and I come along this scale, 10, 20, 30, 40, 45 degrees. As you can see, my measurement is taken closer to the vertex with the smaller circumference, with the smaller protractor. It's still 45 degrees. Look where this circle is, okay? It's very, very close to the vertex. And with the larger protractor, the measurement is taken a lot further from the vertex. However, both of the measurements are the same. And that is the magic of using a protractor. That is how it has been created, and that's just the properties of a circle. A circle, the degrees all the way around a circle will always equal 360 degrees regardless of the size of the circle. And because of that, we're able to use different size protractors. So this is just an introduction to the work that we're going to be doing. Measuring of angles and degrees. An angle is the measurement of space between two lines that have opened around the same vertex. So we're not talking about two lines that have just opened in parallel from each other. They have opened like that. That is the space created between those two lines around a particular vertex is called an angle. Degree. A degree is the measurement of the opening. How much has it opened? We measure that in degrees. Bearing, this is something that we'll leave for now because that's got to do with compasses and direction. Vertex is the point at which those two lines that you're measuring meet. You're going to need to locate the vertex, and then you're going to have to use a protractor to measure. And then finally the protractor. These guys here, if you've got a math set that's only got the 180 degree one, no problem whatsoever, it will still work. If you've got a tiny one, if you've got a massive one like this, you might have to do some extension of the lines, but whether the line is a short one or a long line, it will still sometime cut the protractor's line and you'll get the same answer. So this is just to show you that the measurements that we do are not always going to be, wrong way around, along a straight line. It is very necessary in life to know the degrees of things, especially when you're creating structures, when you're trying to find your way around on a map. All the buildings that we live in are measured with 90-degree angles. That's exactly square. Bicycle frames, they've got angles everywhere. You think about the designing of a car or a laptop or a jungle gym. There's angles everywhere, and they need to be measured with protractors so that everything lines up and it is structurally secure. I hope that this helps, and I hope this is a good introduction for you to understand measuring of angles and degrees. From here we'll take the next step where we start identifying the different types of angles that are out there, the names that we give to them, and then from there we can now move on to more geometry, which is calculating angles in triangles and things like that. It's a very fun exercise. It's a topic all on its own. It doesn't borrow rules from any other topic, so we're not going to be referring to rules from decimals or rules from time or rules from fractions. Angles is one of those topics in maths that's got its own set of rules, and these set of rules you can't share them with any other topic, apart from the basic arithmetic and the adding and subtracting of numbers, things like that. Alright, so I hope you enjoyed this, and I hope that you're able to find yourself a protractor and complete the upcoming work in the days to come.